Okay, students, we are going to continue on looking at our exponents, and we're going to look a little bit more in detail at that division property that we talked real briefly about. You may remember that we said when we were dividing exponents, if they had the same base, what we wanted to do was we were just going to subtract those exponents to get the new exponent. Now, what I want to look at is what happens if when we do that subtraction, we end up with a negative. So, for example, if I have something like 6 to the 4th divided by 6 to the 9th, if I were to follow those rules, it would become 6 to the 4 minus 9, which is a negative 5. So today we're going to be talking about, well, what the heck does that negative 5 mean? And what will we do from there? So let's take a look at some of these together. We're going to start by looking at them in expanded form. And so what I want to do when we're looking at expanded form is I actually want to multiply those out. And so well, not multiply them out, but write them out. So this first one's not going to end up being a negative. We'll do a negative example second. Remember, we talked about this would be the same as 9 times 9 times 9 times 9 times 9 times 9 times 9. Let me see how many I have. 4, 7, 8 times 9 over 9 times 9. And we started crossing out ones that they had in common, and then we just counted and saw we had 9 to the 7th left. Well, let's look at what happens if we reverse that. If we had the larger amount of multiplication in our numerator instead of our denominator. So let's look at a problem like 3 to the 3rd divided by 3 to the 5th. So this time if we expanded it out, we'd have 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3. So if we're crossing these out, we can see that we have more 3's in our denominator. So that would be 3 to the 2nd in the denominator and a 1 in the numerator. Now, if we followed our exponent rules and we subtracted, another way of writing this would be 3 to the negative 2nd power. So that negative is just telling us that the multiplication will be in the denominator of our fraction. Okay, our next example is getting a little bit more complicated. Now we've got multiplication and division in the same problem. So we would want to go ahead and simplify our numerator first. So we have 3 to the 4th times 3 to the 2nd, which would be 3 to the 6th, divided by 3 to the 3rd. Then we would use that subtraction rule. They have the same base, so we subtract 6 minus 3, gives us 3 to the 3rd power. So since that's a positive 3, that just means 3 times 3 times 3. Okay, our next example, again, continuing to make it a little more complicated. So we're multiplying two division problems. So think about these like two fractions. We would multiply the numerators straight across. So in our numerator, we would end up with a to the 17th divided by a to the 10th. Then we would follow our division rule and we would subtract 17 minus 10, gives us a to the 7th power. And finally, our last example, now we're putting all of this together. So we're going to kind of break this apart. I think it's easier when we break these problems apart. So I'm going to look at this as 18 over 6 times x to the 7th over x to the 2nd power. So now I can think of, okay, well, what is 18 divided by 6? Well, that would be 3. And then I'm thinking about, okay, what's my exponent rule here for division? They have the same base, so I keep the base and I subtract. 7 minus 2 is 5. So 3x to the 5th. So go ahead and do some practice problems and we'll check back in soon.